Hi everyone. This week I want to show you how you can use Excel to calculate correlation coefficients when you've collected a lot of quantitative data, like the data sheet I've got here. Now this is data that I've just typed into Excel. And as you can see, I've got 4 columns. I've got a person ID column, a height column, a weight column, and a test score. So for example, person number 5 has got a height of 157 centimeters. They've got a weight of 77 kilograms and a test score of 11. Now, suppose I have a hypothesis that there's a relationship within my sample between the height of people and the weight of people. So what I want to show you here is how you can use Excel to test your hypothesis. Now the first thing that I like to do when I'm comparing two variables like this is to plot them out using some of the graphic capabilities of Excel. Now Excel versions across Mac and PC are a little different, so you might have to play around before you can actually find out how to use the ones in your version of Excel, but I'll show you how I do them using this version. First thing I do is I highlight all the cells that I want to look at in my height column. Next I press down the Command key on a Mac. That's the one with the little apple on it. On a PC I think you might have to press down the Control key, but then you highlight the second column. So I've got the 2 columns highlighted now that I want to test. I then go and bring up my charts and I choose scatter plot. And I finish, and there we go. I'm going to move it over here a bit, and as you can see, it does look like there is a bit of a relationship here, that as people's weight increases here, it looks like as people's height increases, it looks like their weight increases here. Okay, let's see if we can actually get an R value, that is a correlation coefficient, for these values. Now to do that, again, you want to highlight both columns. Well, actually no, there's probably an easier way. Let's do it the easier way. What we do is you type in an empty cell equals Correl, like that, bracket. Then you pick the topmost cell and the bottommost cell that you want to have in your height category. So in this case it's B2 down to B21. So we write B2 colon B21. And then you do the same thing for your weight. So in this case it's C2 down to C21. C2 to C21. And we get a correlation coefficient. I'm going to just put it here so we don't forget. We get an R value of 0.76449. Okay, so this is a positive correlation, as you know from the video. Positive correlations have a positive value, and it's a fairly significant correlation. Because the maximum possible correlation would be 1, and this is 0.76, which is pretty high up there. Okay, let's take a look at a different correlation. Let's get rid of our graph. Let's compare height to test score. So again, what we'll do is we'll put in equals Correl, and height is B2 to B20, and test score is D2 to D20. Okay, and here we have a correlation that's much closer to 0. And so in this case, it doesn't appear there's any kind of correlation. We can double check if we want by simply highlighting both columns like this, and then going back to our scatter plot graph and checking And no, there doesn't appear to be any kind of correlation, positive or negative here. Now, you might ask, well, how do we know whether a value of 0.76 is good or a value of 0.06 is too low or what? Well, as you know, correlations vary. A perfect negative correlation would be negative 1.0. And that would mean as one variable goes up, the other one goes down. A value of 0 means there's no correlation whatsoever. And a value of plus 1.0 means a perfect positive correlation. That means the two variables go up together perfectly in sync. Now, it depends what kind of science you're doing. In the hard sciences, typically people are looking for very precise correlations. Values of 0.9 or 0.95 would be considered a good correlation. In the social sciences, things are much more complex. So we typically say that a negative correlation of, say, negative 0.5 or negative 0.6, negative 0.7, anything from there up to negative 1.0, we consider that to be strong. And likewise, we would consider plus 0.5 to plus 1.0 to be strong. This time it's a strong positive correlation. Values from negative 0.3 to negative 0.5. This is considered moderate. And of course the same for if it's a positive relationship. Moderate. Let me just forgot to put in the dot there. Now anything in between there, anything like 0.2, 0.1, 0, well, we really don't say there's much of a correlation at all. You know, I guess you could argue that there's, you might look at this and say, well, it looks like there's a very small positive correlation. But the truth is, it's probably just randomness. If we had more people, this would probably drop down to 0, or it could go negative, or whatever. But it's not convincing enough that we'd really refer to this as anything at all. It's only when the values get above, say, 0.3 or below negative 0.3 that we would say that we have something of significance here. Okay, so that's just a quick review of how you can use Corel in Excel to test for correlation coefficients. And again, it's just equals Corel, and then you put the two columns that you're comparing in this format with a colon separating them, B2 to B21, and then a comma separating the two columns. Okay, thanks.